Is it live?
Mm-hmm.
All right, let's see if it refreshes. Hi guys. Am I out of frame?
No, you're fine. Fine.
It isn't picking
You
up.
want to stand up and make sure?
Yeah, but it's not picking up yet, so hang on.
Oh.
Live stream. Live dashboard.
Do you see the chat?
Not yet, I don't even see the...
I see someone chatting with you.
Okay.
Or to you.
Sorry, I'm trying to get my local screen up. It isn't showing the live stream for me yet. I am here.
Do you want me to work on that and you can start talking?
No, because I can't see what they're saying yet. How many people are in?
Just one.
How do you see it on there? What does it show up
has
as?
an icon of a person and a number 1.
Okay. That might just be me.
But I saw their chats somehow.
There it is, I found it. I have to click streaming. Okay, there we go. It's saying an error occurred. You're live. Sorry, I am here. Trying to get in. Broadcast.
Wait a second, person joined.
Can you see if they're saying anything?
They're not saying anything.
Okay. Sorry guys, technical difficulty here getting the stream up on my... Wonder if I should keep it private until I go public and then...
No idea.
It's giving me fits here.
I say get us to see the comments.
Well, that's what I'm...
If you have another charger, you can have my phone.
No, I don't want to... I'm trying to just get I don't need it to be mobile. I want to be able to see in full. Okay, there we go. Okay. Oh, Cam, how's it going, man? Oh. I can't see who's in here though now.
That's the only. I forget who the other person was.
No, don't touch it because then it jiggles it. Let me try. Slate in, slates insertion, slate out, adds insertion. Create highlight. Health is good. Sync to preview player, setting never changed. Oh, so you have to view it on watch page. That's how you do it. I'm new at this, sorry. I'm learning. Apparently you view it on your watch page and that's how you do it. So you guys can see the 2 sets of scoops that I have here assembled. I have to glue up my 3rd set.
Not yourself.
My wife is coaching me here. I have to glue up my 3rd set, so I have 2 right now, and I'll be getting done here probably tomorrow. Update with what, Cameron? It's a Q&A session, so basically just kind of here's my current progress. I give it a chance for you guys to ask questions. Is my volume okay? Okay, good. So right now, what we're looking at is just 2 scoop pairs. I don't have, of course, the main shaft in here. It's just the furling tube that I'm doing the mount on, and the the scoops are able to open and close, but I don't have them glued to the furling tube right now, because if I did that, then I'd have problems if I needed to move things around. I'm just starting to assemble. So for right now, these small gears, the furling gears, are just sliding and riding on the furling tube. Normally they'll be fixed to the tube, and then as the furling tube is rotated, all of the scoops would open and close at the same time. They wouldn't be able to do it independently like they are right now. So they're just both kind of independently opening and closing at the moment because I don't have the furling tube fixed. But I can't have it fixed if I'm assembling it still. So I'm gonna swap out, I got this PVC pipe, so I'm gonna swap these pieces out. They were just too cobbled together, and that's why there's tape on it, but good proper piece in for this one and its brother. The 2 on the bottom have correct pieces of PVC in there, so they're good. And at this point, it's just a matter of me getting the time to keep putting the pieces together. There's going to be 5 of these scoop pairs total. We have 2. I'm going to try and see if I can get the 3rd one glued up tomorrow. I would say I'd probably have the ability to get that installed in the next 3 or 4 days for the 3rd level. I'm out of acrylic. I have to go back to my buddy's shop and actually melt more of the large curved pieces though. So thanks, Chris. Once I melt more of these pieces, I need 4 more of those melted to finish layers 4 and 5. So I have enough to do the third layer. So we'll have layer 1, layer 2, and layer 3. But I don't have enough of these curved pieces yet to finish 4 and 5. So maybe I can get out there next weekend to his shop, melt, and form those large pieces. And I think I still need to melt and form 2 more of the smaller ones. So I'm out of material after I get my 3rd scoop pair built. Chris, do you have questions? There's 8 people watching, so if anyone has a question, feel free to hit me up. I know I've been doing a pretty good job in the other live streams to answer questions, so it's understandable. We don't need to make this a stream. It can be 10, 15 minutes. It took me 10 minutes to just get it going. I apologize. I was having difficulty with trying to figure out what I do. Apparently, I have to watch. I said it at the beginning, my preview page or something like that. So, hey Andrew, how's it going? Felipe, how are you? It's gonna be. I mean, I'm still in prototype mode. So, once the prototype, then I can start running it in various wind conditions, the data. And once I start having good data, good results to share with investors, then I can look at getting actual funding for the true startup. Building a manufacturing facility out of an old warehouse, machines, probably some CNC machines to cut the parts. I certainly need room to do the fabrication. I'm hoping to get injection mold plastic in there so that I can actually form each of the scoops with injection plastic. I'd like to couple with Precious Plastics. It's a company where they're using recycled plastics to get the scoops and get the materials, the raw materials for doing that. I don't want to have to deal with acrylic pieces and gluing them up and CNC cutting them and all that. I'd rather just dies and then use injection mold to make the scoops. And then we would probably do aluminum gears in the production models. So there will be mounting holes in the scoop that we would just screw the aluminum gears right on, done. So you'd be, in a mass production situation, much nicer for the assembly line and setup. What is MPPT, Go Vertical? I'm sorry, I'm not familiar with that. And yeah, Cameron, the gears will be made out of metal. The scoops right now, plan is to test plastic, and if that's not sufficient, then we would move up to aluminum scoops, but that'll raise the price significantly, and I'd rather avoid that if possible. So, do I have any email that we can talk a little offline? Yeah, Chris, my email address is chris@creatingmore.com. I need to update my webpage, I'm sorry, but people that make it into the live streams, I make sure I give that out to them. So chris@creatingmore.com will get that to me. Go Vertical, can anyone answer what MPPT stands for? I'm not sure what that is. This would be the scoops when they're about 50% closed. And as I've said many times, the scoops will furl down to whatever they need to drop their RPMs to the safe limit. So that's the advantage of Harmony. It can furl as it's spinning, it'll just furl live while it's running, and the RPMs drop down to where they need to be. Power conversion circuit to reduce back EMF at the all right, so you're using a lot of terms that are necessary in the horizontal axis wind turbine. They have to do something and things like that. I think you're talking about with Go Vertical, and they do a lot of things to try and control the turbine itself because they don't have a good way of controlling its power curve. With Harmony, your power curve, I explained in my last live stream, Harmony's power curve, as the wind goes up, it's going to climb just like any normal wind turbine. And when it gets to its peak desired, you know, let's say 20 miles an hour is where you're producing maximum power. With a normal turbine, and we'll say the same thing with this size of Harmony, you would hit your peak production. In a standard horizontal wind turbine or even other vertical axis wind turbines that are out there, they then have to start doing the things that you're referring to, dumping load and doing all kinds of other things for the maximum power point. And their power point will drop off drastically as the wind speed continues to increase higher and higher. Harmony, when it goes up and hits its peak, it will straight line going across, and it'll just have that straight line going across for, you know, I don't want to say to infinity because that's ridiculous, but it would be an extremely long straight line. We keep furling down more and more and more as it's running at its maximum rated RPM, still producing maximum power for you, where the other turbines have to start doing load dumping and you have to have power conversion circuits and all kinds of things. They'll even use magnetic braking and use the coils themselves to start braking and slowing it down, where Harmony will not to do that. It'll just happily keep running at its maximum rate of RPM. So it's a bit of a different paradigm shift. You have to kind of get your mind out of the old way of thinking with the wind turbines, because the furling capability that Harmony introduces without a physical break in it, you get no loss of power. You get no reduction in your power output because of that. Does that help to make sense, Go Vertical? And it looks cool. It's actually going to be exciting when we see what our maximum output is for the turbine being the size that it is. It'll be 5 scoops. You know, each of the pairs is about 4 feet in diameter across. And it'll be interesting to see what kind of power output we get from it. So, you know, at a 50% close state, which is what I kind of furled it down to right now, you know, it'll be really, really neat to see if 100% open is our most efficient. It might be that it's more efficient to run 80% opened. It, you know, I use the analogy of the ballerina or skating person. When the ice skater pulls in their arms after they start rotating, they'll go faster and faster and faster. We may have that effect actually helping us here, because as pulling in, it'll allow it to spin faster and faster. At a certain point, there will be a balance where we find the peak performance in 10 mile an hour winds, in 15 mile an hour winds, in 20 mile an hour winds. We'll kind of chart that. And because it has the ability to furl dynamically, it'll open and close to whatever the peak furling percentage would be in a given wind speed. So that's a pretty cool capability there, kind of like tuning to the wind. Go Vertical, you keep talking about the back EMF, and you're just talking about the hit that you get on a coil after the magnet passes that, after it passes by the coil. So when you're talking about back EMF, if you have full wave bridge rectifiers on them, that pretty much negates your back if you dump straight into DC. Would you agree with that statement? He might be gone now. I'm looking to have these basically solids dumping straight. Each one is going to be have a full wave bridge rectifier on it for each and every coil will have its own full wave bridge rectifier, then dumping into a DC bus going to your DC power, you know, whether it's a battery bank or to a grid tie inverter or something. He might be gone. That's okay. I know it's late, guys, so I don't want to do a really long chat here. I will stay and answer, but if no one has any questions, I just wanted to show where I was at, show how it's coming along, and I will be getting my third layer put on hopefully in the next couple days here, but then I've got to actually go melt some more acrylic pieces because I'm out of these large curved ones. I have to go form them in the oven to get them melted to how they're supposed to be before I can glue them up. But yeah, things are shaping up pretty well. It's very interesting. And this is because the gears aren't glued in at the moment. It's very interesting seeing how you can furl and unfurl with very, very little effort. I know it looks like I'm pushing hard right now, but it's because the whole thing wants to turn. There's no set point. I can't lock my shaft right now because everything. So I just have to kind of hold on to the other scoop or something to be able to unfurl at the moment. It's a little bit of a pain. But once all the stack is assembled and I fasten the furling gears to the furling tube, then that'll solve that problem. And when the furling tube is spun, all of the scoops are going to open and close simultaneously. All right. Well, it doesn't look like we have any more questions. We had 8 people watching, so thank you to everyone. I just wanted to do a little quick update, get the word out. Hi, Harold. How are you? You're asking me a new thought would be a low RPM, generally speaking, windmill. Harmony is going to be a fairly low RPM windmill. I mean, it's in mile-an-hour winds, which is about 5 meters per second. It's going to be spinning this size. The larger they are, the slower they spin. I mean, it's just a point of physics. It will spin at, I believe when I did the math on it, it was somewhere in the neighborhood of 80 RPM in a 10-mile-an-hour wind. But, you know, I would say that's pretty slow, or, you know, maybe what you're referring to as a low RPM windmill. Maybe you're referring to something even lower than that, but 80 RPMs is pretty slow. For a small, you know, the huge massive ones spin really, really slow, but for something this size, 80 RPM isn't that fast. Thank you, Felipe. I look forward to completing it too. Yeah, Cameron, yeah, 350, is that on low or is that on high? That's probably on high speed that you're doing 350, but I know. Yeah, I can't imagine that in a 10-mile-an-hour wind, if it's going 80, that we'd want this thing spinning more than, I would imagine 400 RPM would be about where I'd want to top out. Even that might be too fast. Maybe we'd want to top out at only 300 RPM. Until we get it out in the field and we really start testing in the various wind speeds, I'm not going to know. It's going to be really, really interesting to see what kind of power output we get from it in the various wind speeds and how fast it is turning, because the algorithms right now where you're returning back into the wind do reduce your RPM speed. You can't just take your circumference times the meters per second and all that stuff. It's got a little bit of finesse in those calculations. And yeah, I could sit here all day doing calculations, but what's the point? To build it, test it, get the numbers, get the funding, get the company going. I mean, who cares? As long as it's producing power in an efficient manner and you're getting your money back in 5 years, people are going to be happy. And if I can make the purchase on them 8,000 or less per unit, I think that's going to be a home run. So would be to be getting somewhere in the neighborhood of 800 to 1,000 watts of power in 10-mile-an-hour winds. We'll see if that's possible. I don't know. So Harold, balancing the windmill, it's already taken care of inherently. Each of the lobes, as they open and close, are balanced. There's nothing would ever get out of balance with it unless a part was broken. So each of the 5 scoops are all opening and closing together. They're not going to be like scoop number 1 is furled 50%, scoop number 2 is furled 20%. Even if that was the case, you still would have a perfectly balanced situation because they're both diametrically opposed along its axes. So your 2 lobes are just like any 2 masses hanging out from the center of their center point of rotation. You can move them in and out, whatever you do, as long as they stay the same distance from the center, you're always going to be balanced. Yeah, I'm sure sunlight's going to affect it if it's plastic, so that's going to call for significant testing and making sure build a robust enough turbine to handle that, Cameron. So, Chris, this thing's not going to be 300 feet in the air. It's not going to be 100 feet in the air. I mean, people could put it up there if they wanted, but what you're really dealing with in the case of Harmony is you'd have a generator either mounted on the ground or like up in your attic, and then sticking out of the generator is going to be a very beefy, heavy-duty, probably like a hollow pole or a hollow tube, whatever you want to think of it as. And then Harmony's driving main drive shaft right now using as a 1-inch cold rolled steel shaft. It'll be about 7 feet long. 5 feet of it will be embedded, just with the turbines, and then 2 feet of it will be sticking out the bottom. You would kind of lock that down into the generator's tube. And then once that's locked in, really at that point, the only thing that you would have with a tube, or not a tube, I'm sorry, a shaft that would be prone to swaying or flexing is really just that 1-inch cold rolled steel shaft. And the size, I think a 1-inch cold rolled steel shaft is going to be, we'll see, if it turns out to beef that up, then we will. Yeah, I agree. We have to be careful that we size the materials appropriately, but I have to start somewhere. I have to go at this. My buddy works in a sign shop. He owns a sign shop. He did his calculations for me in 100-mile-an-hour winds with the mass that we have here, and he wasn't even taking into account rotation. He was just taking brute force wind hitting that from the side, and it should be sufficient with my 1-inch cold rolled steel, according to those calculations. The fact that we're spinning should help to dissipate loads considerably anyway. You're welcome, Harold. Thank you. Cameron, the generator, yes, the ultimate dream, the pipe dream here, my patent is 1 for the turbine scoops and 1 for the generator. I had to pick which technology I was going to kind of roll out to get this company started. I started with the turbine scoops since that's going to be a fairly easy thing for people to see, easy for people to understand. It'll get them excited. And then we can couple Harmony's turbine scoops with an off-the-shelf generator in the very beginning, just till we get it out to the beta sites and start getting numbers. And in the meantime, when we're gathering that data, we're gathering those numbers, we can be working on finishing the our own generator. Yes, I do want to direct couple this to our generator, so you've got our wind scoops and our generator all one unit. Harold, did you have any further questions? Yeah, Chris, I mean, sure. You have on big, tall wind turbines, vertical axis wind turbines especially, you'll see guy wires coming off the top, spreading out. I don't think that's going to be necessary in this. If it is for the prototype, because I've underestimated how strong my central shaft needs to be, then that's good data for me. It tells me, ooh, I'm going to need to beef up my central shaft. It's a prototype. Its job is to gather data and get us numbers. If we find that the top is swaying more than we want it to, then we will put guy wires on the prototype. But the goal would be not to have them in the production model, just increase the size of that central shaft so that we didn't need that. Hopefully that helps. Thank you, Harold. You have a good night too. Wow, we have 10 online, guys. I think that's a record for us. We had 9 the other night, so we just hit 10. Well, hopefully I answered your question. I can't even talk. Hopefully I answered your question, Chris. That was almost a tongue twister. Okay. I think, tell how long we've been going here. That's kind of weird. The other one was showing, oh, there we go. We've been going for about 30 minutes. So if no one has any further questions. Okay, Chris, that's fine. Yep, I'm always happy to email with people. Okay, I think I'm gonna sign off for now, guys. So this is just 2 of the scoops. I'm gonna try and get the 3rd one on in the next couple days here, and then I go melt some more of the backer pieces and maybe even 1 or 2 of the front pieces. And I need to get busy building the cart, because that this thing locks down into is going to house the off-the-shelf generator that I have. I have a 1,000-watt generator, 3-phase generator, and I need to do a little bit of probably a 4-to-1 ratio there with pulleys, tooth pulleys, whatever they're called, like I have in my milling machine here. They're just a belt with teeth on them, tooth belt, I don't know what they call them. But some way to go from 1 rotation Harmony to like 4 rotations at the generator shaft. Because that generator that I have, the one I bought, is probably going to need around 300 RPM to really start producing good power. So we'll see how it goes. Thanks. I don't know how awesome I am. I'm just trying my best, and I'm sorry that it's being long, but hey Gerard, thank you from Mexico. That's awesome. I'm sorry it's taking long, guys. I know I've been working on this for it might be 8 months. I don't know, 8 or 9 months. It's just a lot to do when you're alone and you don't really have any funding behind you other than I do have the Benton grant, which I got 6 months ago. I'm great. It has helped me to get the machines behind me finished up so that I could produce the parts that I needed for Harmony. And now I'm fully capable to produce everything I need. It's just, it takes time. You know, it all comes down to time and money. And I don't have a lot of either right now, so I'm working as fast as I can and putting the updates out to help the community stay informed. Anyway, all right, I think I'm going to sign off and wish you all a good evening. Take care.